Hey,
Hey, how's it going?
good. How are you?
Pretty good.
So good time to talk?
Yeah.
Cool. Uh, so yeah, I've been working in backend systems in Bay Area, in both startups and big companies. Uh, yeah. So may I know one line, like a brief background?
With
That
me? Sure. Yeah. So I guess I'm a senior studying computer science at a college, and I'm kind of just doing this interview prep for new grad roles and things like that. I've done a couple of internships before.
Mhm.
But yeah.
All right. Cool. So I'm hopeful that you will have something to learn out of all these sessions. Uh, what's your favorite language?
For interviews, I usually just go with Python, so I'll just switch that over.
Cool. All right. So let's jump into the problem. So let's say, uh, let me put this in. Okay. So think of an array of integers. Okay. So So in this case, what you have to do is you cannot take the neighbor elements together. What I mean, but at the same time, you have uh, to maximize the profit. Okay.
Okay.
So what I mean by this, in this case, right? So let's say if you have picked two, for example, right? Then you cannot pick three.
Okay.
So in this case, the maximum sum would be 2 plus 2 because 2 plus 2 is 4, which is greater than 3.
Okay.
Okay. Second case, line number 6, right? Uh, there are possibilities like you can have 1 plus 3 or 2 plus 1 or we can have 1 plus 1, right?
Right.
The maximum of these is 4. So 4 is the maximum value, right? And here, the last one, right? As you can see, you can have possibilities like 5 plus 1, right? Or no, sorry, uh, 5,
5 plus 3, I guess.
yeah, 5 plus 3,
And the
or
max is 16, right? In this.
1, 11, or or 5 plus 11, right? So maximum of all these three is 16, right?
Right.
So yeah, so the problem statement is given an array of integers, right? You can assume they are non-negative, right? What is the maximum sum that you can get uh, with the constraint that you cannot connect two adjacent numbers?
Sure. So I guess just phrasing the problem just to make sure I understand this correctly, I have an array of unsorted numbers that are all non-negative, and I basically have at each index the option to add that to some sum
Hmm.
or not add that to the sum, with the constraint that if the previous index was added to the sum, then the current index can't be. So
Right.
let's try and go through one of the examples I gave. So 2, 3, 2. It seems like at each index, I have the option to either pick it or not pick it.
Exactly.
And the only time that I would want to not pick a number is if it turns out that the previous number was picked, right?
Hmm.
As soon as I don't pick a number, that means that the next number can be picked,
Right.
right? This to me sounds like pretty familiar to maybe like other DP type problems where basically I would want to have, say, some n length array where n is the length of the input array, and I would want to have going down an array where I either pick a value or I don't pick a value, right?
Hmm.
Let's see how that goes down with this example. So this is my pick and then don't pick. Let's say that at index 0, my option of picking is 2, and then the maximum sum for not picking is 0, right? When I get to index 1, what that's going to mean is that my maximum value for picking here has to be my don't pick of the previous one
Okay.
plus the current value, right? But my don't pick, I think, should end up being the maximum between my previous value of either my pick or don't pick. So here it should end up being 2, right, is my don't pick option. Because if I don't pick last time, I can choose to not pick again. But I think realistically, it's almost always going to be my don't pick is the value of my previous pick, right? Then finally, I get to the third index, or I guess index 2. My pick again at this point seems like it's going to be, my don't pick of the previous one plus my current pick. So I'll end up with 4. And my don't pick is just going to end up being, should be the max between my don't pick of the previous value or my pick of the previous value, so 3. And then finally, I should be able to give my answer as the max between the don't pick or the pick of the last index.
Okay.
I want to say that this should work out because I've exhausted all the possible options, right? It's just either I pick an item or I don't at each index. So for this, I end up getting my linear runtime and linear space complexity solution. Yeah. Given that, is it okay if I code this out?
Yeah, go ahead with this, and we can.
Pick is equal to 0 for underscore in range len state n is equal to len of array in range 10, then don't pick is equal to 0 for range n. Cool. So my pick of 0 is going to end up equaling r of 0, and from here on, it seems like I can just start from the first index. Range in range 1, comma n. Pick -1. Don't pick -1. There's 2 things I said would happen, right? My pick of int pretty much ends up equaling my don't pick of int -1 plus r of int, and then I said that my don't pick of int is going to end up equaling the max between my don't pick r -1 and my pick, not r -1, int -1, and my pick of int -1. I don't know if I necessarily need this max, because to me it seems like it's always the case that, between the 2 previous maxes, it's always going to be the pick that has higher value, right? But that's actually not necessarily true. If I think about it, it's only because these numbers are really close together, but it may be the case that my don't pick at the previous value is like this giant number because the value right before is like huge, right? Yeah, so I think I do still end up needing this max, not for this case, but some other cases. Yeah, so that should be most of it, and I think the thing that I really need to check for is some edge cases, like say the array is none, or the len of the array is equal to 0. In that case, I just return 0. And this is to, avoid the out of bounds I might get with, say, on line 29.
I think
this ends up. Sorry.
I think line 33. You have to put closing parenthesis.
Oh yeah. Yeah, but past the syntax error there, I think this ends up being pretty much the translation of my ideas in a code. Is it okay if I run this on some test cases? Sure. Okay, so let's say the basic ones that we have from earlier. Before we actually run it, I'm going to try and reason through it. So maximum sum on this value. Before I run this code, let's just say I'm on, I enter this, and I'm at line 26. My n is 3, so I have don't pick and pick all initialized to be length 3. My pick at 0 is going to end up equaling 2. And so now I'm at index 1. I say that my pick at index 1 is going to become the don't pick of -1 plus the current index. So I have the state I mentioned before, where my pick at index 1 is equal to 3. Then my don't pick, again, is equal to the previous don't pick, or pick index -1. So now it's updated to 2. That's correct. I get to index equals 2, and I say that my pick of end is equal to don't pick -1 plus the current value. So I get 4, just like my sample showed it should. And my don't pick, again, it ends up being the max between the previous values of don't pick or pick. So this ends up with 3. And now finally I return 4 as my result on line 35. So this test case seems to be okay. I think it'll be pretty extensive to get one of those test cases where...
Can you run this code?
Yeah, so if I run this, I get 4 is the correct answer. I'm going to go ahead and run this with the other test cases you gave, and then hopefully come up with some more. So I should get 4 and 16 for these ones as well. Cool, so those are all right. Let's think of the test case that I was mentioning from before, where it may turn out that my don't pick, I actually need to care about the max between them, right? So let's say I have like 150, 3.
Mm-hmm.
No, that's not that example. I'd still end up picking a pick of -1, right? So let's say 51 and a 3. How would this work out? So my initial don't pick at index 1 is going to be 50, but my pick at index 1 is going to be 1. And so here, my don't pick at index 2 should similarly end up being, 50, right? It definitely shouldn't be 1. It should be 50. So this is a case right here where the max ends up being relevant. Yeah. But my pick case, I don't know if it makes a difference for correctness by the end, because my pick case is still going to be 53, right?
Mm-hmm.
Which is, yeah, the correct answer. And then I guess just some other edge cases of empty array, and I give it none. Those should similarly be that correct answers. Cool. So given this, I think that's my final solution.
So what's the space complexity? You have written O of n, right?
Yeah, I said O of n, yeah.
Can you optimize on space complexity?
Yeah, sure. So when I'm going through, it turns out that I don't actually need all of the previous items. So really, I can just say pick is equal to r of 0, and then don't pick is equal to 0, right? And so here I should have just don't pick. I can update both of these items at the same time because I'm using Python. So let's just go with pick is equal to don't pick plus r of int, and then don't pick is equal to don't pick comma pick, the max between them.
Okay.
And then I should just be able to return the max between pick comma don't pick. Let's see. Yeah. These all turn out correct as well.
Okay, 1 second. Pick. So pick would be don't pick plus array this, and don't pick is maximum of pick. Okay.
Or don't pick. Yeah.
I see. All right. Sure. So can we try with some negative? Yeah, although I said they are all positive numbers, right? Let's try with. I just put one of them as negative, just to see. 3.
Cool. Yeah, so it still gives me the correct option of 3.
Right. Okay. All right. So now let's do some changes in this. So think of array as a circular one.
Okay.
Okay. So by circular one, what I mean that, so let's say this particular case, line number 8, right? Right. So we chose 5 and 11, right? Can you see me typing line number 8?
Yep.
Okay. Okay. So now think like that this array is circular. So in that case, if you choose 11, you cannot choose 5 and vice versa.
Right.
Okay. So if we go by that way, right, then we have, I think 8 would be the maximum sum. 3 plus
Right.
3 plus 5, no, 12 would be 1 plus 12, 1 plus 11, 12, right?
Okay.
So, so think of array as a circular one. So the last element of the array is a neighbor of the first element of the array. Okay.
Right.
So can you write another method which works in that fashion?
Sure. So it seems like for this approach, you can't do it in linear time just because you are going to need information about, the very first element when you get to the end, right? Um, so it seems like, actually, no, that changes quite a bit of stuff because I was thinking that you would just have an edge case, which in the condition that you end up actually um, getting to the final element, you would just pick, or you would just see uh, what the don't pick and pick values of your 0th index element are, but that doesn't really work out, right? Because that doesn't give you information of what picks you made afterwards. So if this was longer and it turns out that you picked 5 and then you picked 3 again over here, let's say, and then 2 or something, you're going to lose out information, right? So let me try and make a longer test case, just so I can reason about what it would be like a bit more. So let's say it's 5, 1, 3, 2, 11. The optimal here is pretty much okay. I need let's just say it's 3 and 11 is going to be the actual solution here, right? Which gives me 14. How would I figure that out? Because it seems like my don't pick or my pick for index 0, that's not really relevant because by the time I get to say index 3 or sorry index 2, if I have my don't pick and pick values here, which are going to be 8 and 5 respectively, there's no way for me to know whether these 8 and 5 include the first element, right?
Right.
Yeah. So a really easy thing I guess I could do is I should be able to just have as the simplest case is I should be able to have a flag, which oh no, that wasn't going to work out. I was going to say that you can have a flag which indicates whether your current value includes the first value, and then when you get to the last value, you would just subtract your summed value. You would just subtract the first element from your summed value, right? But that won't get you the correct solution all of the time. So say we had 1 and 11. In that case, it wouldn't work out to just subtract the 5 from the beginning because you wouldn't have ever picked that 1 to begin with, right? So it seems to me like I'm thinking that you should be able to do this in linear time, but it seems almost like you can't.
Okay. What's the limitation you have right now? The limitation, or let me rephrase it. How is this problem different than previous one? The difference is,
Because
yeah.
sure, okay, you can. Oh, did
Go
you
ahead.
want me to word it, or are we going to just say it?
Yeah, go ahead. Go ahead. What is the
Yeah.
difference
So,
between the previous one and this problem?
yeah. So the main difference between the previous one and this one seems like for the previous one, I didn't really have to care about which ones I really picked, right? So it didn't matter which numbers I picked, in the sense that their position didn't matter. Or say, I get to this value 12. I didn't care that 12 was composed of, a 1 plus 11, right? I just cared about what the final value is. Versus here, I care about what the individual numbers are composed of, or the
You
individual sums are composed of.
so let's correct that sentence again. You don't care if uh, if middle elements have been considered. All you care is the first and the last.
Right.
Correct?
Yeah.
Correct. So, is there a way? So, what it means that this is the same problem as the previous one. Uh, if you handle the terminal numbers in a different way, if you
Right.
keep one terminal element, because these terminal elements are mutually exclusive, right? If one is present, other won't be, right?
Right.
So, uh,
Okay. I see what you're getting at here. So I do have the option of using, say, two separate loops, right? Uh, yeah. If I One really simple solution approach that is linear time is I go through once and I say that my maximum number is all of the values except excluding the final number, and then I go through a second time where I do the pick and don't pick, excluding the first element.
okay.
Yeah, and that should end up being correct. So uh, that's still linear time, constant space. Is it okay if I try to code that out? Like, do you get what I mean with that?
Mhm.
Okay, sure. So let's say that my highest is equal to 0,
Write a
and I'm going to
write a different function.
write a different function, sure. So let me just call this, let me comment this out.
Mm, those comments are fine. Right, yeah, right.
Yeah, maximum sum
Circular,
looped
yeah, loop.
on the array. Let's say that I'm going to have same conditions as before, where I want to have this. I mean, for the most part, the code is the same, right? So I'm just going to copy the code over to start off with, and then update it. Because my pick and don't pick are still going to be 0, and then I'm going to say that my highest is equal to 0. And then all I'll have here is highest is equal to max pick and don't pick. And the difference is that instead of going to the index 1, I'll go to index n minus 1. Then a separate time, I'm going to loop through again. And I'm going to say that I'm going to go from index 2 all the way to index n. Except what I'll do is that my pick is going to equal r of 1. And my don't pick, again, is still going to equal 0. And now I want to return the max of highest, pick, and don't pick at this point. And so there is still a potential out of bounds error here. Previously, I just checked that the length of the array is 0, but now I have to also check for a potential out of bounds in the case that my array is length 2, right? So really, I think I can handle that as a special case. If my array is length 2, then I just return the max of the array. So that solves the out of bounds problem. I think this ends up being the correct translation of the idea that I had earlier. Is it okay if I try this with some test cases?
Mm-hmm.
Okay, cool. Let's just copy over what I had from before and just use maximum sum looped. So let's try and reason about what the solutions here would be. Oh, was this just run?
I just clean it up, yeah.
Okay, cool. So we got 3, which is correct, 4, which is still correct, 12, Yep, that looks right. And we got 50. Uh, yeah, these look to be okay.
Hmm. One second.
For the 50 example, we only picked the first element, right, and not anything else. And here we should get 11 because still we just returned the max between the two items.
Right.
Cool. So given that, I guess I'll have that as my solution.
Okay. So, yeah, and the reason I told you to write a separate method is ideally in this case, you could have called the method itself maximum sum once with 0 to n minus 1, another times with 1 to n. That's it. That is.
Right.
Mhm.
I'd have to rewrite the maximum sum array though, just because if I end up calling it on a subset of the array, then I'm taking linear space, right?
Right. So, but yeah, this looks okay. Right. And what's the complexity of this?
Yeah, so this ends up being a linear time and constant space complexity.
Cool. All right. Yeah, this looks good. Uh, okay, since we have time, if you want, I can ask you another problem. But
Sure. I mean,
uh,
if you want to end it there, then we could do that. But I'm definitely down to do another one.
sorry.
If you had time to do another one, then sure, I would be interested.
Okay. So okay, let's try with the problem. Okay. So think of right. Let's say you have an array. Mm, one, two, four, like that. Uh, and think of it as a number for now, and then you have set of operator.
Okay.
Assume all operators have equal precedence, and you do like evaluation from left to right, whatever is the standard way, right? Uh,
Okay.
Given this input, what's the maximum value that you can achieve? Okay, using these operators. So what I mean is like one of the probabilities 1 plus 4 equal to 8. Okay. Another you can do is 1 plus 3 times 4, which is 13. I think that's the maximum value that you can get out of this equation.
Right.
You can use any operator any number of times, but uh, you can use one number only just once and in the same order as they are in the input array.
Gotcha. Okay, so I guess some clarifying constraints. Am I guaranteed that the values are going to be positive, or can they also be negative?
And be negative.
Okay, so values can be negative, and I guess 0 is still like a valid number in this, right?
Mm-hmm.
0 is a valid number. Okay, that was just mainly for the division portion. So trying to reason about this,
If it
it's
makes it easier, you can remove zero constant. Assume that it's a non-zero. That's totally
okay.
fine.
All right. None of the values are all non-zero. Cool. That would have probably just been a small edge case anyways. So reasoning about how this ends up working out, I think what I can basically do is from each item, I would go ahead and say, because I have to include every item, I'm going to start off with the sum, or I'm going to start off with 0 as my initial value. And I should be able to say that for each pick, meaning each index, from my initial value, I'm going to try to divide it, try to subtract it, try to add it, and try to multiply it, in a recursive approach.
Mm-hmm.
And between all of the different approaches, I repeat this in a sort of I end up repeating this with all picks and all possible options in a sort of exponential complexity approach where because I'll have 4 branches in my recursive calls, I'll have like a 4 to the n solution that ultimately I can just pick the max of all possible calculated solutions. I don't know if that was clear. Basically what I'm proposing is go through each index one by one, try each of the operations on the index, keep track of a global max, and then return that global max after computing. Ends up taking big O of 4 to the n complexity. Runtime, and it's going to end up taking me for big O of n space complexity, where n is the length of the number array. And that's because of the stack size. I think a lot of this is in the details of the code, so is it okay if I try and code this out?
Yeah.
Cool. So def maximum value on num array, and I guess the plus, minus, times, divide, that's always going to be like constant, right? I'll always have those values.
Mm-hmm.
Like I don't need to take that as input, right?
What as an input?
This on line 85.
Yeah, you can assume, yeah.
Cool. So it's always going to be plus, minus, times, division. Got it. Okay. So now I have def directed maximum value, which is going to take an array, a pick, and a summed. And I'll have my highest is going to equal float of negative infinity as the lowest possible value. And in the end, I'll just want to return highest. Okay. Right, so starting off for the first element, we have the option to either include the negative version of that element or the positive version of that element using, using a division or a multiplication for the very first element doesn't make sense. So we'll include this as a kind of off as a special case. We'll say that we're going to make, we're going to call this with either, oh, I don't need array, I just need pick and sum. We either start off at the first pick value with r of 0, or we start off at the first pick value with negative r of 0. And what we want to say inside of our inner function is basically if we made all of our picks, at that point we are going to say that highest is equal, or highest of 0 is equal to max of highest of 0, so the existing highest value or what we have in sum, and we return. Otherwise, for this pick value, we are going to recurse on pick plus 1 sum plus r of ind, or it's going to be minus r of ind, or it's going to be times r of ind, or it's going to be divided by r of ind. This seems to be the main translation of the idea I had, but let's see if that actually works out correctly. So I start off, I have 1 through 4. I pick positive 1, and now my index is 1. I decide to add 3, and then I decide to add 4. Let's backtrack. I decide to subtract 4. I backtrack. I decide to multiply 4. Yeah, the operator definitely seems to be in the correct location relative to the number itself.
Let me understand this part. I'm not very conversant with Python 3. So a method inside a method is possible, right?
Yeah.
Okay, and here, what is this first parameter to the function? What is pick?
Basically, pick is going to be the index that we are currently processing. So because doing, like, the way to imagine this is that I'm saying that I have 1. So far, my summed is equal. Let me put some comments. My summed is equal to r of 0, and I have processed up to index 1, or my summed is equal to negative r of 0, and I have processed up to index 1.
Okay.
So when I say that pick is equal to the length of r, it means I have processed up to all of the elements in the array.
Okay. Okay.
And so at that point, I've done all possible, multiplications, divisions, right?
Got it.
Because we said that the numbers are all non-zero, I don't have to do a special case on the division, but normally I would say that if r of int is equal to 0, or sorry, not equal to 0, only in that case I would do that, right? Yeah.
Can you try to
I think, sure. So print maximum value on 1, 3, 4. Int is not defined. Oh, it's because I called it pick every time. Oh, I forgot to comment out the stuff from earlier. What I got here, I think, was 16, right? I don't know which number of those were my solution.
Yeah. 16.
Yeah, I got 16, which is definitely not correct. I don't see how
No, that is
that
correct.
would be possible.
Right?
3 times 4 is 12, plus 1 is 13, right?
Right. Okay. Yeah.
So, right, let's reason through what we ended up doing here. The very first time, I have 1 as my value. So I say directed maximum sum of r of 0, which is just 1. And for this 1, what I want to do is from here, okay, it's because of the order of operations, right?
Mm-hmm.
So here, what I have, my solution is 16 because I have 1 plus 3 times 4.
All right.
So I assumed when I was talking about this that the numbers are just being processed from left to right, but when you meant that order of operations applies, you meant like regular orders of operations.
Yeah. So in that case, yeah, 1 plus 3 times 4. So,
Yeah, so that definitely changes my solution by quite a bit in that now I can't just make my sums as I go along. Instead, I'm going to need to have some sort of stack, right?
Mm-hmm.
Yeah, I'll definitely need some sort of stack to figure out the order of operations. So obviously multiplication, division, they're in the same order, plus, minus, they're in the same order. So instead of me just updating my summed every time, what I should end up doing is keeping track of some current, partial, right? And my partial is just going to be the current values that I have, as well as say potentially any of the operations I've conducted. Yeah. So how would I?
Can I run for one more input? Let's see. It should be, so this should be 32. 1 minus 12 times minus 3.
So this is the same as the previous one, right? It's basically taking -1 and then adding that with the 12, right? With -12.
Yeah, yeah. Yeah, so in this case, yeah, I mean, I think it should ideally, like when I said like precedence and all, right? So it should be this times minus 3. So that would be minus 11 times minus 3. which is 33, right?
Oh, yeah. So what this is doing instead, wait, why would it be 33 as the final result?
So
Negative
1,
11.
yeah, 1 minus 12 times minus 3.
I mean, isn't it supposed to be negative? If it's only left to right press, like that's not following BEDMAS, right?
Hmm?
If it was following BEDMAS, what that would end up being is you have negative 12 times negative 3 is 36 plus 1, right? Which gives you 37. If you're saying that it's going to go from left to right and you want to get the max, then it should be negative 1 minus 12 times negative 3 if you're just processing from left to right, right?
Okay, yeah, yeah, correct.
Uh,
Okay.
so so is it supposed to be following BEDMAS or just left to right?
Uh, I think the solution is correct. Like now I see it. Yeah,
Oh, I see. So it is just processing left to right.
left to right. Yeah.
Got it. Okay, yeah. In that case, this should be okay.
Yeah.
Um, it's definitely a lot more complicated if you have to follow order of operations.
Right. Yeah. So as I said, there's no like yeah precedence or anything like that. So just do it from left to right. Cool.
Cool.
This sounds correct to me. I think you can reduce this complexity from 4 base power n to something lesser than that. Uh, but yeah, I think all you need is at any point of time you need to have a maximum and a minimum value previously, and based on the apply the operators with the current value on that, and to get to max and min.
Right. Yeah. Just for the negative values, I guess.
So that way, I think this is your 4 raised power n, right? In that case, it would be 4n, not 4 raised power n, not an exponential solution.
I see. Okay, which is like say significantly better.
Yeah. So
Cool.
cool. I think sounds good to me. I'll definitely write feedback, but in general, I think you are very good. Really good in communication and explaining the problem. Uh, so yeah, I think you're good.
Cool. I'm just curious, are you just like doing this in your spare time or like also practicing for interviews or yeah.
Sorry, say it again.
Are you also practicing for interviews or are you just kind of doing this in your spare time? Like,
Uh,
as the interviewer.
Spare time. I used to practice earlier, but yeah, not anymore.
Cool. Gotcha. Um, anyways, I guess thank you for your time.
Thanks. Thanks. Good luck.
Thank
Bye.
you and have a good day. Bye.
Thank you.